Hello everyone and welcome to the launch of PONDERFUL, the new EU-funded Horizon 2020 project which is investigating how ponds can help us better protect freshwater biodiversity and adapt to and mitigate the impacts of climate change. I'm Jeremy Biggs from the Freshwater Habitats Trust in the UK and I'll be chairing today's meeting and introducing you to the speakers. I'm talking to you from Cutslow Meadows on the edge of Oxford in the UK, where for the last 15 years or so we in Freshwater Habitats Trust have been creating ponds like the one you can see behind me, and where now with our partners we're testing new methods for protecting some of Britain's most endangered wetland plants. I'm very pleased to say that nearly 700 people from 40 countries around the world have registered for today's meeting, showing just how much interest there is in the protection and management of ponds. Today we have 5 speakers introducing you to PONDERFUL, starting with Dr. Tobias Salathe from the Ramsar Convention Secretariat in Geneva, who will be opening the meeting and then introducing us to Ramsar's Resolution 1321 on the conservation and management of small wetlands, including ponds, which is one of the world's most important policy documents helping to encourage the protection of these vital small freshwater habitats. The project will then be formally introduced by Professor Sandra Brucet of the University of Vic in Spain, who's the project leader, and she'll be talking about the overall aims and objectives of the project, and will be followed by Professors Luc de Mester and Oertli from Belgium and Switzerland, respectively, who, between them over the last 25 years, have done much to create a basic understanding of the ecology and management of ponds, and who'll be talking in more detail about the work of PONDERFUL and also reviewing the current state of knowledge of ponds from a biodiversity and climate change perspective. Our final speaker is Professor Lenore Fahrig from Carlton University in Canada, whose work on habitat fragmentation has helped transform the way we think about landscape conservation globally, and in particular has emphasised the importance of small habitats like ponds for biodiversity. So I'll hand over my screen to Tobias now to open the meeting officially, and I'll just finish by saying that I hope we'll see many of you regularly over the next 4 years of the project, and that together we'll be able to create a project working with these marvellous freshwater habitats that really is PONDERFUL.
Hello to everybody. I assume you hear me well. I'm Tobias Salathe from the Secretariat of the Convention on Wetlands, where I'm speaking to you from. And those 171 parties of the Convention on Wetlands, they have adopted a resolution on the conservation and management of small wetlands. This resolution provides an overview of the human-induced pressures on small wetlands and a framework for global action to improve the status of those wetlands. The PONDERFUL project can certainly very much contribute basic but also specific information, data and understanding to this program of action. Notably, we are looking forward to the opportunity of the project to submit to the countries who should be willing to carry this forward into the policymaking process, a number of responses to the following points which are mentioned in the resolution, which I assume has been shared with you. A clarification what exactly is meant by small wetlands that may well include springs, ponds, headwater streams, and others. Maybe elements to fill the current gaps in our understanding of the functioning of small wetlands, of their spatial distribution, and of their connection and connectivity inside the relevant water catchments. Possibly also a clarification of their roles in the hydrological cycle in the water catchments they are situated in, and as critical refuges for biodiversity, of course. We would hope to receive also increased insight into the place of ponds as a landscape heritage and their association with human settlements in urban and rural areas. A better understanding how to respond to human pressures on small wetlands, on ponds, and how to integrate this into national policies and planning cycles. And finally, provide communication means, communication as such, and outreach, awareness tools, and activities to increase the recognition of small wetlands or ponds and their ecosystem functions. I am convinced, and I see from the huge audience we are this afternoon or now, that by doing so, the PONDERFUL project and its outputs would significantly support the scientific and technical work of the Convention on Wetlands and provide the Convention's review panel on such issues with precious elements to develop more detailed guidance based on the one which was just adopted in general terms for small wetlands. And as a last point, a kind of a scoop for our next COP, which is likely to be postponed a little bit due to the COVID pandemic, will only take place at the end of next year. There is already a new resolution in the making, which would bring this forward. So there is time also for the PONDERFUL experts to have their input into this. With this, I think I have been sufficiently long, and I wish us all a very successful meeting and obviously then a successful project. And thanks again for having invited me to speak on behalf of the Convention on Wetlands, and I'm looking forward to what is coming now.
Thank you very much, Tobias. If I can just get hold of the screen here. You can unshare your screen, Tobias.
I'll do it. Let me just check. Can the host do it for me? No.
I'm just trying to do that now.
I do not see his presentation anymore.
No, I've got you, Sandra. I can't see me at the moment. I can only see me at the top. So perhaps I'll just I'll just speak from here. I hope everybody can hear me. So just to say thank you very much, Tobias, for that very supportive and interesting welcome to the PONDERFUL launch. This is now me, real live, Jeremy Biggs from the Freshwater Habitats Trust, chairing the rest of the meeting this afternoon as we move on to the main presentations about PONDERFUL. And it gives me great pleasure first to introduce Professor Sandra Brucet from the University of Vic in Spain, who is leading the PONDERFUL project. And she's going to be giving the first of today's presentations, introducing you to the project to talk about its overall aims and objectives. So Sandra, I will hand over to you now.
Thank you very much, Jeremy and Tobias, for this nice introduction and welcoming. As the coordinator of the PONDERFUL project and on behalf of the whole consortium, I would like to thank you very much, all of you, for joining us in the launch of our project. It's really nice to see how many people is interested in ponds and small waters in general. And we really hope that you will enjoy the presentations of this afternoon. So now I'm going to share you the screen. Okay, so I guess that now you can see it. Is it fine?
Yes.
I do not, okay, because I do not see the faces. So I'm going to introduce this PONDERFUL project that, as Jeremy mentioned, it's an Horizon 2020 Research and Innovation project funded by the European Commission, and that started already last December and will last for 4 years. And as far as we know, PONDERFUL, it's the largest European research project so far tackling the conservation and ecology of ponds and their role in climate change mitigation. You can see here that we are a big consortium composed of 18 partners in total from 11 countries. 8 of them are European countries: Sweden, Denmark, Germany, Belgium, Switzerland, France, Spain, and Portugal. And there are also 3 partners from UK, 1 from Turkey, and 1 from Uruguay. And here I only included the IPs from the different institutions, but there are many more participants involved with different backgrounds and areas of expertise that goes from ecology, pond conservation, modeling, social and political sciences, environmental economics, etc. As you probably know, and Lenore will explain us later in her talk, it was traditionally assumed that large habitats like rivers or lakes were key for freshwater biodiversity conservation, and that the small size of ponds made them less important. However, unfortunately, the research over the last 15 to 20 years is changing this perception, because it shows that ponds are one of the most abundant and richest freshwater habitats, representing 30 to 50% of the standing waters worldwide. And they have proved to be critical for they have proved to be critical biodiversity hotspots, an important refuge for rare plants and animals. In Europe, for example, ponds support up to 70% of the regional species pool. And there are studies that show that ponds have more rare, endemic, and threatened species than rivers or lakes. The ponds also deliver multiple ecosystem services, including provisioning of water, flood control, groundwater recharge, pollution amelioration, recreation, tourism, etc. And although there is little knowledge on the role that ponds and small water bodies in general play in mitigating climate change, the few studies that exist show that they may have a significant role in carbon sequestration, but also on emissions. Yeah, okay. I'm not sure if the slides are changing automatically. Maybe I will have to stop for a moment, but I continue. However, in spite of the great importance of ponds, they have been largely neglected in European policies related to water and nature, including the Water Framework Directive, that for most countries set a limit of 15 hectares to the water bodies that it applies. There are also sections of ponds being included in EU directive. For example, some Mediterranean temporary ponds, which are included in the Habitat Directive as priority habitats because of the plant species that live in them. And the fact that ponds are largely omitted from monitoring programs and EU directive is, of course, really problematic, because ponds are exposed to the same threats that face large waters, like land use or water use or pollution, and they may be particularly vulnerable to climate change because they are less buffered to temperature extremes and changes in hydrology. In fact, in most European countries, the number of ponds has declined a lot over the past century, with losses over 50% in many European countries and occasionally reaching 90%, for example, in Netherlands, Switzerland, or some parts of Germany. And this concern was highlighted by IPBES in the Regional Assessment of Biodiversity and Ecosystem Services for Europe and Central Asia. The same assessment also highlighted the lack of freshwater biodiversity data, particularly invertebrates, as a critical knowledge gap for biodiversity conservation. Additionally, although ponds have multiple functions, they are not it's changing automatically, sorry. So I was saying that, that although ponds have multiple functions, they are not commonly applied as nature-based solutions. And this is due to barriers and challenges that hamper their development and management, such as knowledge gaps on the policy or and the social context of ponds, or knowledge gaps on the costs and benefits of pond implementation as nature-based solution. Okay. So with all this background in mind, we designed the PONDERFUL project with the main objective to provide data and guidance to make more and better use of ponds and pondscapes, so the networks of ponds, as nature-based solutions for climate change mitigation and adaptation, biodiversity conservation, and delivery of ecosystem services. And we will do this by generating and integrating biodiversity, ecosystem, social, economic, and policy knowledge, and by providing also evidence-based guidance and tools for pond nature-based solution implementation. So the specific aims of PONDERFUL are, first of all, to develop an approach to strongly engage with the stakeholders, so as to be sure that they are able to implement the benefit of ponds as nature-based solutions. PONDERFUL will also evaluate the interactions and feedbacks between biodiversity, ecosystem services, and climate in ponds. And this is being done by generating new data of biodiversity and ecosystem services of ponds at multiple spatial scales. PONDERFUL is also developing models to predict the impact of climate change on biodiversity and ecosystem services for different land uses and pondscape scenarios. Another important objective is to develop and test the implementation of pond nature-based solution in close collaboration with the stakeholders. And this will be done by creating a set of demonstration sites across Europe where pond nature-based solutions are already implemented. And finally, of course, we will make sure that the outputs of PONDERFUL are widely known by policymakers, practitioners, and stakeholders. And above all, one of the PONDERFUL objectives is to provide data for supporting the recommendation from this review paper that you see on the screen, recently published by Van Ries et al. About the new global biodiversity framework. And I quote what the paper says. New strategies that should address the bias in research management and policy principally focus on rivers and lakes and largely excluding other freshwater habitats. So PONDERFUL aims to provide critical data and policy support to address this bias that exists towards large water bodies. And how are we going to do all this? PONDERFUL is structured in these 4 different parts that you see on the screen. This different 4 work package. We have our package focused on the involvement of stakeholders, policy, socioeconomics, and sustainable financing. Another one that is focusing on the effects of climate change on biodiversity, ecosystem functions, and services and their interactions. One on scenarios and modeling the impacts of climate change. And another one using ponds as nature-based solutions to mitigate and adapt to climate change. So and I will present you these 4 work packages of PONDERFUL. As I said, one of the work packages is focused on the stakeholder involvement, policy, socioeconomics, and sustainable financing. And here, our main aim is to develop a multidimensional framework that supports the effective, efficient, and equitable implementation of pondscapes as nature-based solutions. This first work package is very important because ponds are affected by socioeconomic factors, which include policy, economic incentive, or the perceptions that the society has about ponds. And all these socioeconomic factors can drive the protection of pondscapes, but they can also place barriers. So the main aim of this work package is to understand how policy, economics, and the public perceptions affect ponds, and to identify how we can use these factors to increase the implementation of pondscapes as nature-based solutions. So the first task will be to explore the social perception of ponds and their importance for the delivery of ecosystem services, or what it's very similar, the nature contributions to people, that it's an approach proposed by IBES, which is very similar to the ecosystem services. So by doing questionnaires, we're going to analyze how pondscapes as providers of ecosystem services are perceived by residents and stakeholders. PONDERFUL will also analyze the policy context of the ponds at different levels, from local to European scale, and will identify the enabling factors and the barriers for implementing pond nature-based solutions. And other important task will be to assess which are the instruments to finance pondscape nature-based solutions, and also analyze the economic context of ponds, focusing on the economic assessment of the risk associated to ponds nature-based solution. This is another work package of PONDERFUL, which is evaluating the interactions and feedbacks between biodiversity, ecosystem services, and climate in pondscapes at multiple spatial scales. And this work package will be explained in detail in the next presentation by Thomas Mehner. So I will only introduce you here the main task, which are the following. So first of all, we are going to evaluate how pond biodiversity varies across a large climate gradient, including Europe and Uruguay. We will also document ecosystem functions and services of ponds and analyze the interrelations between biodiversity, ecosystem functions, and services across the climate gradient. And here we are particularly investing a lot of effort on the analysis of the greenhouse gas production and carbon trapping by ponds. We will also assess how hydroperiod shapes the interactions among biodiversity, ecosystem functions, and services. And finally, we will analyze the vulnerability, resistance, and resilience of pond biodiversity and ecosystem functions and services to climate change. So to achieve this objective, we are going to use different methods. We are going to compile a pan-European database of existing data on biodiversity, environmental conditions, and land use. We are also performing a large-scale stratified sampling in 8 countries across Europe and Uruguay, the ones that you see, these green numbers that you see in this map. And in each of these countries, we will perform the standardized sampling of 30 ponds, including both permanent and temporary ponds. And we will generate a data set on environmental conditions, biodiversity, and ecosystem functions that will be also used later to fit the modeling exercises to forecast the effects of climate change on pondscapes. There will also be specific case studies to address stability and the resilience of pond biodiversity and ecosystem functions to climate change that Thomas will explain you later. And finally, we will also use a long-term running experiment in Denmark, the Lemming experiment, to assess the effects of climate change on biodiversity and upon ecosystem functioning. So here you can see some nice pictures of the biodiversity sampling that it's taking place this spring in different countries. This is being an intense sampling, as you can imagine, but I think that we are all enjoying it a lot, and surely the hard work will pay off. These are some pictures of the biodiversity sampling in Denmark and Spain. Here, another picture of the biodiversity sampling in Switzerland. Another one on the EDNA sampling in UK. Here, the UK team sampling biodiversity under the rain. Sorry, and here the University of Vic and University of Girona team sampling the greenhouse gases in the ponds of Catalonia in Spain in better weather conditions. Here another picture of the details of the greenhouse gas chambers that we are using to analyze the gases continuously. This sampling will be repeated again this summer, even when the ponds are dry, and then again in autumn and winter. So another objective of PONDERFUL it's being developed in parallel to the sampling, and it's the model and the development of a modeling framework to predict the impacts of climate change on biodiversity and ecosystem services for different land uses and pondscape scenarios. And here, the modelers will co-develop scenarios of pond management using information from the stratified sampling as well as from the demonstration sites, which I later will show you. So to do so, they will take into account the stakeholder needs, the management strategies, and also the projected trends in land use and climate change. They will also develop an integrative and predictive modeling framework by incorporating the empirical relationships between biodiversity, ecosystem services, and connectivity, and the projections of climate change, hydrological change, and land use change. And finally, based on the modeling outputs and scenarios and in co-development with the stakeholders also, PONDERFUL will produce priority maps for intervention. So the idea is to produce maps that will assess where the management of pondscapes would contribute most to biodiversity conservation and climate change mitigation and adaptation. These priority areas for intervention will be, for example, regions where ponds will suffer higher impacts from climate change or land use, and so that will require, conservation measures to be put in place. Or, for example, regions where investing in better management may lead to greater climate mitigation. Another main objective of PONDERFUL it's related to the use of ponds as nature-based solutions. And here we aim to develop guidance for planning and management of ponds as nature-based solutions, which will focus on the use of ponds for climate change adaptation and mitigation, delivery of ecosystem services and functions, and biodiversity conservation. So to achieve this objective, we have set up a network of demonstration sites in Europe and Uruguay, where pond nature-based solutions have already been implemented. And then we will develop a set of tools for decision makers and local practitioners to promote and guide implementation of these pond nature-based solutions. Here, I will only briefly introduce your work on the pond nature-based solutions and the demonstration sites. And later, Oertli will give you a presentation about this work package. So we have already selected the demonstration sites in 8 countries, in 8 European countries and Uruguay, where the pond nature-based solution have already been implemented. And you can see them in the map, the red dots. Each of these demo sites will be characterized in terms of its ecosystem services, biodiversity, economic benefits, and potential for mitigation of climate change. And then we will show how ponds can provide different ecosystem services or nature contribution to people following the projects developed by IPES. And these nature contributions to people are, for example, those ones listed here in the slide, like the provision of clean water, new habitat creation, carbon trapping, pollination, etc. And finally, our final aim is to highlight the best practice strategies in the implementation of the pond nature-based solutions. So here you can see some of the selected demonstration sites. Beth will show you more later. This is the demo site in Belgium, where 16 ponds were restored, managed, or created. And these are the native contributions to people that this demo site provides. So similar to the ecosystem services that they provide. So this pondscape provide new habitats for increasing biodiversity in general, and they are also breeding sites for amphibians like the crested newt. People is using this demo site for hiking or for being in contact with nature. And also, finally, these ponds also have a buffer capacity. Here, there is another example. This is one of the demo sites in Spain, in Catalonia. And here, the nature-based solution implemented is the restoration of ponds. Specifically, with the aim to recover the ecological values of the salt marshes that you see in these pictures, and their capacity to buffer the effect of the marine intrusion during sea storms. So here, the new ponds were created to provide habitat for the endemic Iberian tooth carp and eel. And they are also used by people to walk and be in contact with nature. And also, as I said, to buffer the effect of marine intrusions. And the ponds are also trapping carbon. More details and examples will be given by Beth in his presentation. So by developing all these objectives and tasks that I have introduced you, we expect that PONDERFUL will make significant impact in relation to pond biodiversity conservation, ecosystem service, and climate change mitigation and adaptation. And the impacts that we expect from PONDERFUL are summarized in these following slides. So the expected scientific impacts, some of the expected scientific impacts of PONDERFUL will be first, large-scale assessment of the critical role of ponds and pondscapes in maintaining freshwater biodiversity and climate resilience. Also, the quantification of the mechanistic links between pond biodiversity, ecosystem services, and climate. The quantification of the contribution of ponds for climate change mitigation and adaptation, which will be done by analyzing carbon storage and greenhouse emissions at different climates. The prediction of pond responses to climate change and land use scenarios, and the identification of the best practices for pond nature-based solution implementation. And finally, in relation to the societal and policy impact, PONDERFUL is investing a lot of effort on providing support for the recent work that demonstrates that the small habitats are far more important than traditionally considered. Particularly, we expect to show that better protection of ponds and small water bodies in general could help address the biodiversity crisis. Because ponds are biodiversity hotspots, because they are also stepping stone habitats, and because they provide critical habitats for uncommon and rare species. And also because ponds are small habitats, which makes them easy to manage and protect, and they are also cheap to make. So they provide major biodiversity gains with all investing modest expenses. PONDERFUL will also promote the integration of ponds into policies to reach biodiversity, ecosystem services, and climate change objective. And in this sense, we expect that the evidence from the project will help support refinements of the environmental policy. And last but not least, PONDERFUL will also provide the stakeholders with tools to use pondscapes as nature-based solutions to increase resilience of societies and ecosystems to global change. Or, as we say in Catalan, el pot petit i a la bona confitura, which translates literally into English as the best jam is in a small jars. Thank you.
Thank you very much, Sandra. That's brilliant. Let's just get my video back and let's see if I can share my screen to everyone. Okay. No, that's still not working. Can you see? Can you see me on the screen, Sandra? Okay or not?
Yeah, yeah, very small, but yeah.
Oh, you've got the small screen. I'm trying to get the big screen back.
Yeah.
How's that?
No, now we are seeing your your screen share.
Oh, I'm sorry. Sorry, I'll stop the sharing. Okay. Thank you very much, Sandra. I'm just going to leave you there and talk from the top of the screen, which is probably where you can see me at the moment. So that was a really helpful introduction to PONDERFUL. There were a few questions. We have time for a few questions. And actually, I was going to just ask you to expand on one of the things that we've been talking about quite a lot, which is where we think best to interact with policymakers. I know you've had some experience with IPBES. Do you have any views about how we can best make these interactions with policymakers? Because that does seem to be quite an important barrier and problem that we will need to overcome.
Yes, this is true. In fact, we were already talking with policymakers how we could do this. And well, they recommend us that they should be involved from the very beginning of the project. I think that we are more or less accomplishing this. And then we should also be involved in IPBES as well, and also in the nature-based solution task forces that are being led by the European Commission. And then, well, in fact, one of the the policymakers in these task forces recommend us that it's very important to write a policy brief, but as well to appear in the media very often and in important journals. And well, also at local scale, we are going to involve stakeholders and policymakers specifically during the workshops that will take place 3 times during in 3 different years. That this is part of work package 1 on a stakeholder involvement.
Okay, lovely, thank you. I've got a couple more here. We've got time for a couple more, rather more specific questions about the details of the project. There was a question asking us literally, what are we counting as ponds in the project? What sizes, what sort of depths of water body? Probably just worth telling people the kinds of water bodies that we're looking at.
Yeah, I think in the project we wrote a limit of 10 hectares, but then in the stratified sampling, I think we were selecting a little bit smaller ponds, around less than 5 hectares. Maybe Thomas can correct me later. And then this project, it's all the tasks are focused on freshwater ponds, but we will also try to include brackish ponds and saline ponds in the pan-European database. So when we are compiling the existing data on pond biodiversity, then our aim is also include this kind of ponds.
And actually, I can see in some of the chat there are, but people will be interested in, I think, in these detailed definitions of what constitutes a pond. And probably it's quite good to look across at the literature, because quite a lot of this information is actually in the literature out there, whether it's, I'm just looking at some of the Q&A now, whether the water bodies should be natural or artificial, whether they're drainage systems or not. I think we have quite a broad definition in the project, don't we, essentially?
Yeah. We are also including urban ponds. There is a specific case study that Thomas will present on urban ponds, for example, and natural ponds, of course. And then I see here that they are asking whether we will include all the gradients from oligo to eutrophic. Yes, this will also be explained by Thomas. So in the stratified sampling, we are covering different land uses. So we have 3 levels, so low land use, medium, and high. And in the different countries, we are sampling ponds from these land uses.
Okay, I think that was, there was one question. I was going to just take another question a moment, if I could see where I wrote it down. I think, yeah, I think this perhaps will come in the next questions, in the next talk, but there was a question about, are we having standard methods for greenhouse gas measurement? And I think I know what the answer to that is, but I'll let you say that.
Yeah, of course. All is in the stratified sampling. All is standardized. So we are running the same standard methods in the different countries. And well, I guess Thomas again will give you more details. This is led by the University of Aarhus, by Tom Davidson. And well, we are measuring the greenhouse gases with the chambers that you saw in this picture, and that will be further explained by Thomas. And it's a continuous sampling for several weeks, and then repeated 3 times in a year, and repeated again for some ponds next year in a resampling.
Lovely, thank you. And actually, this one I rather thought people might ask you, and this might be this will put you on the spot a bit, I think, this question, I'm afraid. And that's one that a lot of people will be wanting to know how they can, whether there are ways of joining in with Ponderful and participating, and how we build that. And I think that's quite a complicated answer, but I'll let you.
Yeah. So now, first of all, it's not possible to include more partners in the consortium, because this is a project by the European Commission and everything is set. But there are particularly two tasks that, we would be happy to have some collaboration, or if people could provide existing data. And one is in the elaboration of the pan-European database that Thomas will explain you later, that we are compiling data on biodiversity, existing data on biodiversity, to assess the interrelationship between biodiversity and ecosystem services. And here we would be happy to have data from other countries that are outside PONDERFUL. But of course, we need to check first whether this data it's useful for the objective that we want to run. Then there is another task in Work Package 4 that will be presented by Beat, where we are compiling a data set on nature-based solutions based on ponds. Okay, and here, in fact, we will ask for help to people outside the consortium that can have some restoration projects or management projects on ponds, we will send you some. We are creating an Excel sheet with questions about this initiative. So this is another possibility to collaborate. And finally, of course, we can also commit our time, for example, when we are preparing policy brief. So we do not want to show only what is happening in the countries of the consortium. We also want to show examples that are outside the consortium, no? And we could support you in this sense, no? To provide more, let's say, so to disseminate your the project that you are carrying out.
Yeah, okay. I'm going to call the questions to an end for a moment, but I will just say to everyone, do keep writing your questions down, because we will collect up these questions after all the speeches, and the ones that we haven't answered during the meeting, we will come back to you after the meeting and answer them to maintain the connections with you. And do just write to Sandra or to me to say that you're interested, and we'll talk about that in the project and try to find ways of working with you, including that could be all the things that Sandra's been suggesting, or developing future projects together or something like that. And also we'll be interacting a lot with the European Pond Conservation Network, who will also have opportunities to help encourage connections to people, and we'll send you some more information from those in the future as well. So thank you very much, Sandra. That was a great start. I hope everyone found that a useful way of getting an overview of the project. And we'll turn to the next speaker now. I'm grateful to the technical team who are making a much better job of swapping my screen over than I was, so that's very helpful, thank you. So we're going to move on now into the detail of the project further and talk more about the details of what we're working on. And I do have to announce here, there is a last minute change here to the program, to the speakers, because very unfortunately because of a personal bereavement in his family, Luc de Mester isn't able to give the presentation that he prepared today. And so we're very grateful for Thomas Mehner, who's part of the project team. He's a colleague of Luc's in Germany. He's the deputy director of IGB, and obviously part of the PONDERFUL Steering Committee, has stepped in relatively last minute to make the presentation to you today. Some of you will probably also be aware that Thomas is the 13th president of the International Society for Limnology, as well as his work in PONDERFUL, which is the world's oldest scientific freshwater society. So he's going to be introducing to you one of the two major themes of PONDERFUL, which is the effect of climate change on biodiversity, ecosystem functions and their interactions in ponds. So I will hand over to you now, Thomas, to get us on into the detail of the project.
Thanks, Jeremy. Thanks a lot for everyone listening to me. And as Jeremy has started telling you already, I had to take over the presentation from Luc de Meester, but this is truly a collaborative work because Luc has prepared all the slides and I have just to deliver the presentation now to you. So I hope you can see the full screen now, okay?
Yeah, that's okay.
Okay, so I want like introducing you a little bit on the work within the work package 2 within PONDERFUL, that is the effect of climate change on biodiversity, ecosystem functions and services, and their interactions in ponds. Let's start with a slide you have seen already before in Sandra's presentation, but we decided to repeat many things just to make clear how important ponds are. So ponds are very numerous. Many of the freshwater habitats worldwide are in fact ponds. They harbor a surprisingly high contribution of regional freshwater species, something I will come back to later again. And also they provide multiple ecosystem services. And in particular, I will go also to some details with respect to carbon storage. That is very important, but please don't forget water provisioning, flood control also have been very important services provided by the ponds. Groundwater recharge is often neglected, and pollution amelioration and recreation also contribute to the ecosystem services of ponds. So we have to consider ponds as really important in mitigating and adapting to climate change. What about pond biodiversity? So let's show a few nice pictures, but also please look on the graphics below. First, on the left-hand side, we have here a plot on the species numbers in several of the freshwater habitats. And macroinvertebrates, these are the small creatures living on or within the bottom substrate in the freshwater. And you see that ponds clearly make it, so they are the winners in the species richness. Ponds have, on average, the highest species diversity, more than rivers, more than lakes, more than the small streams, and more than the ditches. And this is not true only for these macroinvertebrates, for the larvae of insects, but also for wetland plants. We have almost the same order here. Ponds by far have more species than any other freshwater system. And this is very typical that we say, well, biodiversity in ponds is really important to consider. And of course, now you can ask, what is the reason for this huge biodiversity in ponds? Well, there are three big answers to this question. First, ponds are numerous. So there's a sheer huge number in many areas of the world, and therefore biodiversity is just accounted, or biodiversity is just caused by an enormous number of ponds distributed over the country. And what is nicely shown here as well, ponds come at a surprising dimension with respect to ecological variation. There is not something like the pond. Many ponds are totally different to each other, and you see it here nicely in all these pictures. And this simply means we have a variety of different habitats, but also means this is the variety of conditions for different biodiversity. And the third argumentation, and this is nicely illustrated by this aerial picture from cattle holes in Germany, they function as a kind of stepping stones for dispersal. That means ponds harbor here, for example, an amphibian species, and amphibians could disperse to the next pond and could further disperse to the next pond. That means overall, all the amphibians, for example, in these ponds would form a bigger population. And this, of course, saves the population under, say, unhealthy conditions in one of the ponds. Not the entire population of the frogs, the amphibians would disappear, but in many of these other ponds, they could survive and then just re-enter the previously occupied ponds. So we have this kind of situation that numbers, ecological variation, and the stepping stone function all together provide functional understanding why biodiversity in ponds is so high. The second point, which is really important within the context of the project, but also within with respect to the relevance of the PONDERFUL project, which refers to climate regulation. We all talk about carbon, and in particular carbon dioxide, that is responsible for heating the surface of a planet. And one of the solutions to prevent heating would be that the carbon dioxide is removed from the atmosphere. And one mechanism by which it can happen is simply that it is fixed by primary producers. And this also happens within freshwater habitats. So this is not just a function that belongs to forests, for example, but also within water, we have primary producers, algae, and higher plants as well. And if this carbon dioxide would be fixed and later sinks to the bottom, here you see it in this muddy part from the sediment, then in principle, carbon dioxide would be removed. Are ponds important for this climate regulation? Well, let's first check here what we have with respect to rates of carbon burial rates. So what is really entering or what is removed, how much CO2 is removed from the atmosphere into the ponds. And here you have a list of graphics. The temperate grassland do not contribute much to this process. Temperate forests, tropical forests are a little bit better. Lakes are not so bad, wetlands, agricultural land. And then here marine vegetated habitats have something about 130 gram carbon per square meter in year. This seems to be really impressive, but now switch to ponds. This is the same scale, goes up to 500 gram carbon per square meter in year. And you see eutrophic ponds, ponds that have high nutrient concentrations, can help burial of up to 500 gram carbon per square meter in year. So a variety of ponds have different rates, but overall you can see ponds are much more, have a much higher potential to help mitigating this carbon dioxide concentration that is too high in the atmosphere. This would be an easy solution, but where is another side? And we have to turn it around. What's happening with all the carbon in the ponds? Is it permanently buried there? Or can it be that it is released again? And if you consider the carbon cycle in a pond, we have to admit that carbon is also lost from the ponds into the atmosphere. And we have essentially two processes. The first is the so-called diffusive loss of carbon dioxide and methane. Diffusion simply means that these gases would follow a concentration gradient. So if there is a high concentration within the water, carbon dioxide and methane would just diffusively lost from the water into the atmosphere. A second one is ebullition. And ebullition simply means there are bubbles. So you have certainly seen already bubbles coming up to the surface in ponds or other freshwater habitats. And these bubbles often are carbon dioxide or even methane. And what we see here is there is a gradient between highly productive lakes and oligotrophic, so low productive lakes with respect to the methane flux. And the same also with reservoirs, so man-made lakes. But in fact, we don't know anything about these rates from the ponds. And this is, of course, very important to see the balance between carbon burial on the one hand and the ebullition and diffusive loss of climate gases from the ponds. So this is one of the central topics within the PONDERFUL Work Package 2. It is very obvious that the production of carbon dioxide and methane likely depend on the climate. So we need to check the rates across a climatic gradient. It is important to consider eutrophication. I've shown you before the graphs that with increasing nutrient concentration in the water, also the rates of carbon loss from the ponds likely increase. We have to assume that the ecological state of the ponds play a substantial role. And what do we mean with ecological state? Some ponds are totally turbid. turbid, for example, from strong algal blooms, but there also are ponds that are typically clear water lakes, so often totally overgrown by macrophytes. And this difference makes a substantial contribution to the rates of carbon loss from a pond. And here again, we don't know in which way all these factors affect ultimately the release of carbon dioxide and methane from the ponds. And on top, we don't know anything about the biodiversity effects on the methane and carbon dioxide release. So this interaction is something we have to study. So we are aware of the fact that ponds are important for climate mitigation, but we can't evaluate at the moment the extent by which ponds contribute to the climate change related production of greenhouse gases. So this work package 2, and this has been mentioned already by Sandra, will focus on the interactions and feedbacks between biodiversity, ecosystem services, and climate. In particular, focusing also at multiple spatial scales. And the task, this is also repetition. We want to see whether biodiversity varies along a climate gradient, primarily within Europe. We want focusing in particular on the interrelations between biodiversity, ecosystem functions, and services along this gradient. We want to assess how hydroperiod shapes the interactions among biodiversity, ecosystem functions, and services. And we want analyzing the vulnerability, resistance, and resilience of ponds where biodiversity and the ecosystem functions to climate change. I will give you a few examples now how we want to address these tasks. First, and this has been mentioned already by Sandra, we will do a stratified survey on 30 ponds in total 8 European countries plus South America and Uruguay. You see it in the countries included is Denmark, UK, Germany, Belgium, Switzerland, France, Spain, and Turkey. And in each of these countries, we have selected already 30 ponds, by the way, located in different pondscapes. So we have groups of ponds in different pondscapes, and we always try to have a relatively large geographical distribution of these pondscapes to make them independent and not simply replicated sites. We include a well-defined gradient of land use that is normally covering something what we would call near natural until strongly agricultural. And we have this spatially well-defined context that we say, let's have a gradient along the climate, so from north to south and from east to west, but also let's consider that these ponds are often in different landscapes, and therefore the pondscapes are part of different environmental settings. One of the biggest challenges and one of the biggest benefits of the other side is a highly standardized sampling protocol. So standardization is the key to this stratified survey. What are we going to analyze, or what is actually currently going on in all the countries? We are going to sample the presence of fish and amphibians by environmental DNA. So if you don't know what it is, it's just a little bit kind of a genetic trace of species left in the water. And with the new, more sophisticated recent methods, you can identify these species from just a few drops of water. We will also record the macrophytes, so all higher plants that grow within and around the ponds. We will focus on the insect larvae living on the bottom of the ponds. And we will focus in particular also on zooplankton, because zooplankton could be the key switching a pond from a permanent, from a turbid to a clear water state. Here again, this sampling protocol was developed in a way that it allows finally to have a fully comparable setting for all samplings. And this is quite a challenge, what I can tell you already now after the first samplings. So here you see again a few of the pictures, several teams from all around Europe. And you see already that this is quite a lot of equipment that the groups have to bring to the places. And therefore also the activity itself does not mean you can easily do many of the ponds, sampling in many of the ponds per day. So usually it takes a couple of hours to have a full sampling inventory per pond. So this stratified survey will at the end allow for the analysis of a climatic gradient. This is just from the organization across Europe and including South America. We will also be able to have included the hydro period. We have not yet mentioned in detail what hydro period means. Hydro period means that not all of the ponds are permanent. So maybe, I don't know where you live, but in many cases we thought the hydro period is an issue in particular from the warmer countries. So more if you are in the south of France or in Spain. But recently we have learned that even in Belgium and Germany and even in Denmark, we have also problems with hydro period, that many ponds simply disappeared after a number of very hot and dry summers. So I personally have encountered accounting recently that from the ponds here around Berlin, the capital of Germany, that have been surveyed during the last years, about 75% dried out and are still without water now. So we have lost an enormous diversity of ponds and therefore also an enormous diversity of biodiversity. And this simply means hydro periods plays a role, and therefore we have enormously invested in also adding ponds that change the water level over the year. And this standardized sampling will also provide us a link to land use in the ecological state, such that with a standardized analysis, we can analyze all these effects. What else will we do? And this was mentioned before by Sandra. Here you can contribute. We want to create a big so-called pan-European database with based on existing data on biodiversity and local environmental conditions within several pond scales all over Europe. Currently, this database is more than 1,600 ponds from 9 countries. We have an ambitious goal. So you see here, we want to come to data from more than 2,500 ponds in more than 15 countries. That will allow us to have an integrated analysis of biodiversity and environmental conditions. Here, the goal is not standardization. These data sets are not fully comparable with respect to the methods. So the sampling was totally different in all these spots here. But nevertheless, by biodiversity data in relation to environmental conditions, this will allow us a huge data set to use for calculations. And therefore, the focus here is on numbers. This simply means also don't be shy to ask us whether you can contribute. The quality of your data is here not defined by the standardized protocol we are using. Your contribution will be of quality anyway, just to create this pan-European database. So the key aims are the broad patterns of biodiversity at European scale. We want analyzing the regional effects, in particular with respect to land use and population density. And we would also like to focus on the spatial effects. So the pond density and the network among ponds. By the way, because I've seen it in the questions before, here in the project, we focus on isolated ponds, so ponds that are not connected by surface waters. They can be connected by groundwater, but not by surface waters, just to see in which way this isolation of ponds has an effect on the species diversity. We also include so-called case studies, and one of the biggest case study is continuation of studies on fish ponds. Fish ponds, as here, this is a nice picture from Belgian fish ponds, are biodiversity hotspots. Furthermore, many of the ponds are differently managed. So few get fish, a few have no fish at all anymore. A few of the ponds are currently more developed with respect to biodiversity, for example, with birds. And therefore, you have a huge variety of different ponds, often located close together. And these fish ponds are often extremely relevant for nature contributions to people. So there's massive recreation, in particular for tourism. A few ponds can be used also for recreational fishing, for example, and education is normally often used, or these sites are used for education. Just to mention, and I will come back to it later again, all these ponds are or will also be used in a scheme to resample, to see whether over a temporal aspect, there is stability in the conditions within the ponds. The same applies also to urban ponds. Urban ponds are a different challenge. Here we have sites in Geneva and in Belgium. These are areas with strong human impact. So very clearly seen here that the gradient of urbanization can be strong. So houses very close to the ponds. And there's relevance because here they have the impact of a mixture of often very strong stressors. So you see here sampling in a very muddy and turbid pond. And certainly there is a strong effect of these anthropogenic deterioration on these ecosystems. Here again, we will do resampling to check how stable are these ponds, even if they are exposed to these strong anthropogenic stresses. And this resampling—
Thomas, just to say, Thomas, just about a bit over 5 minutes to go.
Yeah, I will run through the remaining things. So we want quantifying the stability through time with the fish ponds, urban ponds, and we will also resample a few of the ponds from the stratified surveys. One thing finally to mention, you could think maybe it's very good to dig out a few new ponds, and something what we don't know yet, in which way these new ponds will be colonized. I told you before, all these ponds are not connected. So how fast would it be that biodiversity comes into the pond and will develop here? And this is something that we also will follow up within the work package 2. Finally, I've mentioned these greenhouse gas emissions. We want measuring diffusion and these gas bubbles. And again, this should be measured in a highly standardized way in the 240 ponds I have explained before. So we have the same gradients in climate zone, land use, ecological state, and biodiversity. This will be accompanied by an ongoing project in Denmark. So just a few words again, you have seen this picture before. This looks very fancy, so like an unidentified flying object, but in fact, this is really a construction from garden market substances. And if you count properly, this is 4 here, the number is 4 in one of the ponds. 4 times 30 means we need 120 of these gas chambers. And this is all handmade by the sampling teams. So one of the strongest activity during the last weeks was to prepare these gas chamber sample devices. And at the end, what you can see here, hopefully, the gas that is accumulated within this chamber is taken out and later analyzed. So we can quantify how much gas is trapped inside the chambers, and we can analyze whether it's carbon dioxide or methane. The work package 2 feeds into 2 other, primarily into 2 other work packages. This is one on the scenarios on modeling introduced before by Sandra. In particular, with respect to scenario development, modeling, and integration, because we will record climate, land use, and the spatial networks of the ponds. And the second one is, of course, the relevance of the nature of the survey with respect to the so-called demo sites. Beat will be the next speaker, and he will introduce the details of this one. So we expect the scientific impact. This is very clear. We want to have the assessment of the role of pondscapes in maintaining biodiversity and climate resilience. We will create this pan-European scale study with respect to biodiversity and ecosystem services. And we will hopefully quantify the pond contribution of for climate change mitigation and adaptation. And of course, as I told you, work package 2 will also feed into all the other 5 or 4 work packages. Now I will end the presentation again with a few pictures. So sampling has been and is ongoing currently. Sometimes it's very nice, you have pleasant sights, sometimes you have to walk over long distances and bring all the equipment there. But nevertheless, I think for most of the teams, this is really an enjoyable endeavor to see how variable all these ponds are. Often you have surprises with respect to biodiversity, and ultimately, and this is of course a big part of it, this is an international team where there's a lot of interaction with all the people. And if you once encounter these signs here, then you know this is a pond also covered by PONDERFUL. Thank you.
Brilliant. Thank you very much, Thomas. That's really good. I'm not sure if my screen is going to go side by side again. That would be nice if it did, but I'll carry on. Oh, there we are. Thank you. So we have time for, there are quite a lot of comments and questions in this for this presentation, of course, as we get into the details now. And I'll just reiterate that we won't try and tackle all of these now, but we will come back to all of the answers that aren't we don't give today. And I can see there are some really encouraging suggestions about collaboration as well. So we'll go through all of these later on, but I will just pick out 1 or 2 questions, Thomas, if that's okay.
Yeah.
One of the first, which is, I guess, for all of us quite an important issue, is just about the timing of our results. When do you think, obviously, it's going to take us quite a while to get things into the published literature, but when do you think we might be starting to get some of the first results out from the gas work in particular? I think people were asking about. Do you have a sense of that? Or?
The question is, what do you mean with a result? The first result is that we have filled all the vials. So we will have thousands of vials filled pretty soon. The analysis certainly will start in late autumn this year. And I don't know how quickly it is fixed, but I assume in the middle of next year, we will get a first overview. This is, of course, then not yet scientifically validated, but we will start seeing trends and can start interpreting the gradients.
Okay, lovely, thank you. Just a bit of a question about how we've been choosing sites. Did you, I think I partly know the answer to this from the UK. How hard has it been to find suitable sampling sites? And maybe you could just talk a little bit about tell us a little about the site selection process. Yeah, where you've been involved directly.
Yeah, I love to talk about it because when we started discussing about PONDERFUL a couple of years ago, I thought, at least as a German, this is no issue at all. You just go out and take one of, I don't know, 150,000 ponds you have near Berlin. And then only recently I've realized that many of these ponds dry out, and it's really much more difficult than you thought before. So, of course, in most of the countries, we have some background information where good pondscapes are available that have already been sampled often. So this was a pre-selection, but the final selection of the ponds was simply a personal visit. So all of the ponds and many more had to be visited during the last 6 months, more or less, to be identified. They had to be interpreted with respect to anthropogenic effects, with land use gradients, with respect to the ecological state. And when we have identified, well, we have a group of pondscapes, so larger regional groups of ponds that have to be far distant from each other. And within the pondscapes, we want to have a gradient in land use, in eutrophication, and obviously also with respect to the hydro period. And this was a challenge. So I'm pretty convinced we will not have the optimal solution, but the best we could achieve.
I think I agree with you completely. I think that's one of the things you realize when you start working on small waters, that you can spend as much time finding the sites to work on as you can actually working on them. It's much harder because there are so many of them and they're so varied. That's fabulous. Thank you very much. We're right on time. So I'll say thank you for that excellent presentation of that part of the PONDERFUL work. And we'll move on now to our third main PONDERFUL speaker, Professor Oertli, who I'm sure many of you will already know who are watching this today, is one of Europe's most experienced freshwater biologists and definitely a pond pioneer. Beat's going to be introducing you to the second major theme of Ponderful, which is the ways in which ponds can help us to deliver a whole range of ecosystem services, leading to better land and water management generally. So Beat, you can take over the screen now. I will turn mine off, and we look forward to hearing from you.
Okay, thank you, Jeremy. We take the screen. Okay. It's coming. Yes, I think.
We'll see your emails first, though. That's okay.
Okay. It's working now?
That's fine. Thank you.
Okay. Good afternoon, everybody. We will speak now in this talk from pond nature-based solution, and it's a topic of the Work Package 4 of this project, Ponderful, that I am coordinating together with Pascal Nicolet and also the support in our school of Aurélie Boissezon. You see in this background picture, a picture of a pond. Indeed, this is a nice pond, and it's a restored pond. You know, it's a restored pond. That means that is what we call a nature-based solution, and I will come later during the talk. But to show you that finally a restored pond look like a natural pond. It's in the Rhone floodplain near Geneva in Switzerland. To begin, I like this picture here that is taken from IUCN. I have adapted it, that show in the sense the pondscape in which we can conduct some nature-based solution. We can call them pondscape-based solution. That can be creation of pond, management, restoration. I will come back to this later. And this pondscape with this implemented nature-based solution is able to provide nature contribution to people. And here you are different. That can be, like we have seen with Thomas, carbon trapping. It can be also pollination and food and also on. And this contributes to the human well-being and the biodiversity benefit. And in our Ponderful project, we will develop guidance for planning and management of a pond and pondscape as nature-based solution with the aim of adaptation and mitigation to climate change, biodiversity conservation, and NCP delivery, nature contribution to people. Okay, now to begin, what is a pondscape? You have here a good example of pondscape. It's in Switzerland, Bois de Jussy, near Geneva, and you have the limit of a forest. This can be a limit of a pondscape, but this can be also other type of limit for other pondscape, like ecological setting, a valley, a catchment. Here it's a forest. It's a forest, and inside this forest, you see these yellow dots. These are one and sometimes several ponds. And these ponds are connected, ecological connected. You have some flow, not only from water, but you have flow from animal, and that is important. You have, for example, amphibians that are going from one pond to another. You have also dragonflies that will take another pathway. And so you have an exchange of species that is important, that increase local diversity. This buffer also for species extinction and influence the community structure and the overall biodiversity, also the terrestrial biodiversity that you have in this pondscape. So an important thing is that in a pondscape, you have a connectedness between these ponds. Coming back to the density of pond, I have here a nice picture that is showing that on the planet, you have different density of pond. You have places with low density in yellow, and you have places also with high density. And coming to numbers, that means that high density are part of the planet where you have more than 2 ponds per kilometer square. So you see that even in Europe, you have a blue, yellow, and green area, but also in South America and elsewhere. That means that the pond density is heterogeneous depending on the geographical area. And what is also important to realize is that smaller are the ponds, more numerous they are. Here you have different scale of size. On the right scale, you have the lakes from 10 hectares, and here the three last bars are for ponds, and you see for smaller water body, you have more water body. You have each time 10 times more water body. You can even add here a further bar with less than 100 square meters with more ponds. So that is important. Often they are forgotten, but the small ponds matter a lot, and they are more numerous than the large ponds and lakes. Another important point is that the pond density is heterogeneous also inside each geographical area. Here you have the Mediterranean basin, here you have the Alpine Arc, and in a study conducted by the European Pond Conservation Network about important areas for ponds, they underline the part where they are large density. All the blue spots are parts with particular large density of ponds that matters for biodiversity and also for other reasons. The same for the Alps, the red points are the place where you have the largest density of ponds. What means a large density? In numbers, this is a part where you find more than 40 or 50 ponds by a kilometer square. That means that it's 20 times more than the blue areas that I showed before you on the world map. So these are also what we call the pondscape. We can also pondscape. Pondscape are places where you have aggregation of ponds, and this important area of ponds are also pondscape. Now coming back to Ponderful. What is a pond nature-based solution or a pondscape nature-based solution? Broadly, we can make a difference between four types. One, pond creation, pond restoration, pond management action within the pond or area surrounding the pond, and finally, pondscape scale management action. And in the framework of Ponderful, like Sandra told it, we will make a large-scale inventory in this year and next year of pondscape NBS, and we encourage you also to participate and to give your information about your knowledge on implemented NBS and also on the outcome and result, positive result of the implementation of pondscape NBS. And we will, with this data and also your data, make a large database that will be available for stakeholders on platform, or for example, on the Ponderful website, but also the best practice, we will publish them, for example, on the EU platform like Oertli platform. And finally, to speak again from a pondscape is a large-scale NBS that includes several smaller scale NBS for nature-based solution. Okay, coming to example of NBS, the most common NBS is probably the pond creation. We create still a lot of ponds for various reasons, and this is a good situation, I must say. This is a kind of restoration, because if we look at our landscape yesterday, this was our landscape yesterday. Today, that it was stressed by Sandra before, we have lost about 50 to 90% of the pond. And what we hope for tomorrow is such type of restored landscape with also a lot more of ponds than today. That means also that we have to create pond. We have to create new pond, perhaps in place where there was no pond, but also in place where there was formerly some pond. And now we come here to pond restoration. Pond restoration is creation of a pond in a place where the pond has disappeared. It has disappeared. You see here this nice figure, an infill pond. The first step will be to clear the vegetation. Second, to dig out the sediment, and then you have a restored pond. A good example of restored pond is a program of restoring ghost pond in the UK. What is a ghost pond? A ghost pond is a pond that you don't see. For example, here on this photograph, in this landscape, in this agricultural landscape, you have a pond, you don't see it, but if you dig here, you find first again a pond when it's there is raining, but surprise, you will find here some plants that germinate for the original seed bank. You have an original seed bank, it remains viable about 200 years, and it will germinate. It's the same also for zooplankton, with some propagates that can stay 500 years even and could germinate when you have water. Another type of NBS are the pond management action within the pond. This can be a very routine management measure. For example, water management, you can dry the pond. You can remove the sediment with a big machine, but you can also use some smaller machine. You can mow the vegetation. You can plant the river shore. You can harvest the fish. And there is a lot of other routine management measures. This is within the pond, but this can be also outside the pond. And for example, on the area surrounding, with the example of developing a trail, you can also develop an observatory for fauna. You can also implement a buffer area. In this buffer area, you can create some habitat for the amphibiotic species, as for example, amphibian, reptile, and so on. You can mow the reed, sedge, and rushes that prevent, for example, from landing and for losing water area. You can also fence the area, remove invasive alien plant species, and other type of action. These are only some examples. And finally, you can also have very large-scale NBS. We integrated multi-scale, small-scale NBS. And this example is from the demo site in UK that will be investigated in the framework of PONDERFUL. It is called water friendly farming. And here you have a set of measures to improve the water quality and hold back water. For example, with buffer strips, with leaky dams, with bonded ditches, with changing tillage practice, with also interception ponds and wetlands. Okay, now for a synthesis, I come back again to the example of the pondscape Bois de Jussy in Switzerland near Geneva, where you see this 40 last year, there was a lot of NBS that have been implemented. So one pondscape is in reality a large-scale NBS that accumulated small-scale NBS. And here in this landscape, you had some species reintroduction program with turtle. You have a tree clearing here also you have trails that have been implemented, also observatories. You have ponds that have been digged in these several places and fish removal. These are some examples of what has been done in this pondscape, and that make also this pondscape particularly effective providing ecosystem services. And now I come to this second point. The pondscape and implemented NBS, they deliver nature contribution to people. Nature contribution to people, they have been presented by Sandra, so I will go quickly through them just to show you that you have habitat extension for biodiversity. This has been already developed, regulation of climate, but you have also pollination. You have a regulation of water quantity, quality, regulation of hazard, food and fed, and physical and psychological experience, also learning and inspiration and supporting identity, and finally, maintenance of option. Beginning with some example, prevention of flooding. You have here this nice picture of an urban pond. This has been created 5 years ago near Geneva, and it's intended for prevention of flood in the downstream area. Sometimes you call them a stormwater pond, but you see that it is also valuable for a lot of other reasons. It's functioning like this. You have, for example, a big storm, and we will face in the future a lot of big storm in the summer with a lot of water that will fill in a very short time. And this water can be stored in this pond with also some evapotranspiration. And what is interesting, you see this red line, that you have some delay for devolving this water to the downstream, and also the quantity is lower. So you have a delayed restitution of water and a lower quantity of water. Another NCP is a microclimate refreshing. Another example of pond is called Wellbook. It was restored in the year 2000 from a former wetland. You have here the image of the cart of this pond. And you have in color the simulation of the temperature felt, the physiological equivalent temperature. And you see this nice gradient in color between the pond here that is relatively cold and area surrounding that is really warm. And so that means that you have about 100-meter buffer, 100 buffer area where you have a refreshing air. This is also particularly welcome in the context of climate change and with warming climate. The regulation of water quality is another NCP. Just a small table to recall that we already know it very well. For phosphorus and nitrogen, nutrients are trapped by such type of systems. And pesticide also, there can be also a retention up to 70% in agricultural landscape where you have a lot of ponds. And this photo presents one pond in the Swiss Jura, one pond, a set of 4 ponds that are downstream of a small village, and these ponds were constructed to treat wastewater. So the wastewater is treated in these ponds, and the pond hosts also some rare and threatened species like amphibians, invertebrates, and aquatic plants. So you see that you can also have some cohabitation between these services. Another important nature contribution to people in some parts of Europe and also South America here. Looking for Europe, in the Eastern European country, for Christmas, you eat the Christmas card. So you have also to produce them, for example, in fish pond, and this is a direct outcome of the pond. Another indirect outcome is kettle watering. You have here the example of the pondscape Maldonado in Uruguay. This pondscape will be investigated in the framework of PONDERFUL, and you see here all the dots. It's a dense netscape of pond, and several of them are used for cattle watering, like this photo here, and are really important on the economical point of view. A pond is very important on the economical point of view, and in a study that we have done in the Brazilian Cerrado, an inquiry stressed that the presence of a pond increased the value of a property of 50%. 50% when you have a pond that was used for cattle watering, but also for other type of purposes. Pollination is linked directly to biodiversity. And in this nice study done by Stewart and colleagues, you see here that for bees and overflies, 2 groups of pollinators, you have an increase of the density when you go toward the pond. This is an agricultural landscape. When you have a pond, near the pond, you have much more in number of individual number of bees and overflies. Another, this time important for the society and the physical and psychological experience, and also learning and inspiration to nature contribution to people. Here you see, for example, a demonstration to people of the biodiversity living here. There are macro invertebrates. And in the middle, I think you also are going near the pond on Saturday, Sundays, and perhaps on Sunday when it's shining, and look at the nature, so contact with nature and leisure. Here's the example of boating, but you can also fish, angling. You can also bath in some ponds, and this is important now in summer. And there is increasing demand also of people for bathing in ponds. Okay, now for coming to, again, to a small synthesis, you find here again the pondscape Bois de Jussy in Switzerland with the implemented NBS. Now you understand that the implemented NBS will provide several NCP, you see. And what is important, the cumulative impact. One pond alone will not matter. What matters is a lot of ponds, is the pondscape, and also this cumulative impact, for example, for regulation of water quality, for biodiversity, for physiological, psychological experience, and so on. So it's a cumulative impact of all these NCP, NBS NCP, sorry, that will help us to adapt and mitigate the climate change, to increase the biodiversity, and to deliver NCP and ecosystem services. In PONDERFUL, what are we doing? We are providing tools for guidance for planning and management of pond and pondscape and nature-based solution. First, we have already heard of this network of demo sites, but we will develop also specific tools for guidance with the stakeholders, like, for example, this database of best practice measure, and we wait here for your contribution also. We will develop a technical handbook with a best practice, a policy guidance document, a multi-criteria decision software tool. I will come back to it later, and the proposition of a modular and new NBS climate pond. What is important that we engage and that we have already engaged the diversity of stakeholders. We have already engaged them, and a lot of these stakeholders here have already provided last year a support letter to the PONDERFUL project, and now they are also integrated. And we have met them. We will meet them in a workshop. And these stakeholders are, for example, national, local authorities, NGO, private consultancies, nature reserve, landowner, people from education, researchers, tourism association, army even, and so on. So a very big diversity of stakeholders that is engaged in this project from the beginning to the workshop, for example, ICREA, implementation and monitoring of NBS, assessment of the NBS in the framework of the demo sites. Okay, you have already seen this map, perhaps here another pondscape. This is in Germany. You see these dots. These dots are several ponds that are part of a pondscape, where we make the demonstration of the effectiveness of NBS for climate change mitigation. Another, perhaps an example, before going to an example here, a synthesis. Don't look at this table, this is too large. Just what we know that we have about 5 bioclimatic zones. We have also Turkey here with present a particular bioclimatic zone with various types of land use, with implemented NBS, providing NCP with a mean pondscape area for about 21 kilometer scale, but there is smaller and larger. There is a big diversity of pondscape, like there is a diversity of ponds, there is also a diversity of pondscape, with a mean number of ponds that is about 46 to 120. This is the example of the demo site of Denmark. You have seen before other example. That is a Finn Island, and here, for example, this is the island Birkholm, where you have several ponds here, and all these ponds have been created, redigged, or restored. In the total, in this Finn Island, you have about 80 ponds that have been created. And the objective is, on one side, the creation of habitat for biodiversity. You have here this newt, the crested newt, and sites are in Natura 2000 network. But on another side, the NCP provides also food and feed, because these ponds are used for watering cattle. Okay, so what are we going to do on this pondscape? We will assess them on 3 pillars for this assessment: on biodiversity, on selected taxonomic groups, on NCP that will be chosen in collaboration with the stakeholders, with also measurement of cost and benefit, with measurement of one-off and ongoing cost, and intermediate and final ES, for finally assess the efficiency of the pondscape for climate change adaptation and mitigation for providing biodiversity and delivering of NCPs. For this assessment, we will take the opportunity for a new publication produced last week. It is last month. It is very new. This is a handbook for evaluating the impact of nature-based solution. Very large book, about 1,500 pages, with a good framework presenting the NBS impact assessment, but also a robust set of indicators and methodology. And many of the indicators of our program of assessment, the Pondscape in the demo site, will come from this nature-based solution handbook, and we will test them in this program. Okay, I come slowly to the end with a multi-criteria decision software tool. This is a software tool that will develop on one side with the input of our modelization. They have been presented by Thomas with output and recommendation. And here you have an example, a small figures that show a pondscape today with a poor efficiency for climate change mitigation and adaptation. And in this simulation, you can, for example, simulate the pond creation, the water quality improvement, but you can also simulate other implementations of NBS. And what we expect finally, it's a pondscape of tomorrow that have an improved efficiency for the carbon, for the climate change mitigation and adaptation, producing biodiversity and delivering NCP, is what we expect at the finally, also a quantification of the NCP. To come to the end, here again, these figures that I really like with the transition from NBS to NCP and finally to human well-being. And if we go to 2024, we can conclude or confirm that restore pondscape with well-functioning dense network of good quality ponds enhance our quality of life in the context of climate change. And Ponderful will provide detailed data needed to help achieve this ambition. Thank you for your listening.
Thank you very much, Beat, for that excellent summary of the other major component, the other major part of Ponderful. As you can imagine, that's generated loads of questions and comments because we're doing such a lot of different things here. And I'm going to say again that we will, and I can see many interesting questions there, and we will mostly, we won't have time to deal with those today properly. We'll come back to you with a proper answer after the meeting. To talk about, to answer the questions in detail, to look at opportunities for collaboration and all the other things that you're raising in the chat, in the Q&A, because we will need to keep roughly the schedule, but we do have time for a couple of quicker, not too complicated questions, hopefully. One area that people were asking about, Beat, was the pesticide treatment. Using ponds to treat pesticides and the reductions of the pesticides intercepted by the ponds. Did you have any information, knowledge of what the effects of those pesticides were on the ponds whilst they were being treated? Or was that not part of the, was the main objective just to get the pesticides down and not to worry about the impacts?
Yes, no, it's a good question, and on one side, we must say that we have reduction of pesticide concentration in this pond through different process, physical process, biological process, and so on. And what is the impact on the fauna and flora? I remember for a very, very ancient study of one French ecologist called Ramad, and in his Treaty of Ecology, he presented his results about this topic, but sometimes we forget a very, very ancient study and we do it them again. But I know that presently there is a cost program ongoing in Europe on the impact of pesticides on the amphibian. And I think It has just begun in several countries, also in Switzerland, and we should have more results on this part. I have no results to present you today, but I know that, like I told you, in the ancient literature, you find some data, but also today we will have soon much more information. This is a crucial topic because everywhere in Europe and elsewhere, there is an increasing use of pesticides, also new pesticides and so on, and especially also in Switzerland, where there will be a votation on the topic soon.
Okay, lovely. That was really helpful to know that. Beat, I'm going to leave. There's quite a long list of questions that we will need to answer afterwards. I'm going to.
Problem.
We can work on those later, I think, because
you.
I'd like to move on now to our final speaker today and our special guest today, Professor Lenore Fahrig from Carlton University in Canada. Lenore's going to step back a bit and look at the role of small habitats a bit more generally, with a special mention to ponds, of course. But you will maybe know already that her work has had major influence on the way we think about the management of landscapes generally, not just aquatic habitats, but she's that wonderful person who crosses boundaries and produces results which are really both scientifically significant, but also very important practically. So I'm going to hand over to you, Lenore, to talk about the biodiversity value of small ponds and how to protect them. Though I know you're talking much more widely than that, really.
Yes. All right. Thank you, Jeremy. I'm just going to share my screen here. Okay, well, let me know if you can't hear me, but otherwise I will just assume that you can.
No, that's good. It's all good.
Okay, great, thanks. So thank you very much for inviting me to do this talk at the launch of PONDERFUL, and I've really enjoyed learning all about it, watching the talks this morning. So, right, this is the title of my talk, and it has 4 sections. The first section, I'm going to talk about how small wetlands often have little or no protection. I'm not going to do a global analysis of that. I'm really going to use the place that I live, so the region where I live, as an example of that, and you can compare that to where you live. Then I'm going to, as Jeremy said, talk on a more general level about the value of small patches and including small wetlands. Oh, I'm going to be using the term, we use the term wetland a lot as a more generic term, but we sort of use it interchangeably with ponds when they're small. So on a per area basis, that small wetlands contribute more to biodiversity than large wetlands. Then, so we have this contradiction between the first 2 points, that small wetlands often have little or no protection, even though they contribute so much to biodiversity. So then I'm going to talk a little bit about why I think it's been hard to change this paradigm, that small patches and ponds have low value for biodiversity. And then in the 4th section, I'm going to just go over some of the work that various students in my lab have done on wetlands and how to protect them, particularly by protecting the surrounding landscape and by comparing that to the value of wetland buffers for biodiversity. Okay, so the first section, small wetlands often have little or no protection. As I said, I'm going to focus here on, this is kind of an introduction, I guess. I'm going to focus here on our area of Eastern Ontario, Canada. I failed to put a scale on this, but the region is about 200 kilometers from east to west or north to south. And it used to be quite, there used to be a lot of wetland cover a couple of hundred years ago, and about 75 to 80% of all the wetland has been lost over the last 200 years. Although it's, I noticed currently still in the blue zone of Beat's map there. So we've lost a lot of the wetland. And the main causes of wetland loss are agriculture, urbanization, and roads. So for agriculture, what has happened is tile drainage. So putting rows of tiles in the fields and then draining them into ditches. And this map on the left shows a portion of the region, that most agriculture intensive portion of the region, with the ditches in black lines. So it's covered in black lines, and those are all the ditches that collect the water that's drained off of the land. And so that's been a huge cause of wetland loss, and it's still ongoing. So there's evaluation of remaining wetlands, and even provincially significant wetlands. There is still tile drainage being added to those areas, which is all of the red circles in this kind of close-up of a portion of the region. So the second cause is urbanization. This is the city of Ottawa, Canada's capital, which is in the region and used to be, a couple hundred years ago, mostly wetland as well. And this is just an example of a portion to the west of the city that sort of before and after the wetland on the left side and being converted to urban cover on the right-hand side. And this is still ongoing. This is just from this past March, a protest against development on wetland in in this region, Eastern Ontario. So our current provincial government is not very strong in the environmental area, and so there is still wetland loss happening. So in some of your areas, you may be more concerned about wetland restoration. We're still dealing with wetland loss, and we could be restoring some if we were thinking about it. So the third cause in our area is roads filling wetlands. So we have drainage of wetlands for agriculture and filling of wetlands for urbanization and for roads. So in human-dominated areas like Eastern Ontario, most of what's left is small wetlands or ponds. So on the left, we have a farm pond, and on the right, there's it's an urban pond that's about 200 meters from my front door, and from my house where I am right now. So urban ponds and farm ponds are mostly what's left, and all those ditches, which we also count as ponds. So these areas have little or no protection. So just to give you the example of the system in this province, it's called the Wetland Evaluation System, Ontario Wetland Evaluation System. So this is a system for evaluating the quality of wetlands, the relative quality of different wetlands, which is supposed to translate into protection of those wetlands. Although, as you saw with the tile drainage, even the evaluated wetlands are still subject to some impacts, ongoing impacts and loss. But within that evaluation system, size comes in twice. So wetlands that are smaller than 2 hectares are not evaluated at all. That's smaller than the minimum size that Sandra mentioned earlier of some sort of protection in Europe. But that's also larger than most of the photographs of the wetlands that were in Thomas's presentation, as far as I could tell. So those ones are not evaluated at all, and so not subject to really any kind of protection. And then even for the ones that are larger than that and are evaluated, there are components to that evaluation, and size is one of those. So it's likely that wetlands even larger than 2 hectares are going to have very little protection or attention, even if they're larger, for whatever, because they're not as big as they could be, let's say, or some wetlands are. So size is a big aspect of evaluation of wetland value in our area. So moving to the second part of my talk, so this is, I'm going to sort of zoom out to a more general question about the per area contribution of small patches, including small wetlands, small patches of habitat to biodiversity. And so this is the question. For a given total amount of natural habitat or a given total area of natural habitat, is it better to protect or restore a few large patches or several small patches? So we're controlling for the total amount and just saying, you know, what's better for biodiversity, for having more species, more native species there. Is it better to have a small number of large patches of habitat? You can think of a few large wetlands or lots of little small amount of habitat, a bunch of little ponds that add to the same total area. So this goes way back to the 1970s when Jared Diamond published the hypothesis that a single large patch should hold more species than several small patches of the same total area. So this is a piece out of the figure in his paper. So he had several ideas of what would be better or worse. And idea B, you have a single large patch, a single large circle that represents, you could think of it as a large wetland, and several small patches, you could think of those as 4 smaller ponds. They total the same area. The two sides of this figure total the same area. But the one on the right has several small ponds. So I might use the word fragmentation during my talk as well. And the word is used in very many different ways. So I'll just say that the way I use it is the same as this comparison. So the one on the left, if you have 1 or 2 large patches or ponds versus many small patches or ponds, the many small is more fragmented, but for the same total area. So that's the important thing. So, because we're looking at a per area comparison, so we have to control for area. So this actually, this hypothesis of Diamond's was, it kind of became a standard. And I think one of the main reasons was because it was reproduced. In fact, his figure was reproduced in the IUCN World Conservation Strategy in 1980. So they included that principle, all of Diamond's principles, but I'm especially here the one suggesting that a single large habitat is better than several small ones in their sustainability guide. So it became kind of it went into a policy document quite quickly. So that leads to the question, well, what do the data actually say? Are there actually more species in a single large or a couple of large patches or in several small totaling the same area? So we can consider a set of patches like this. So this is the typical type of study that's been done to address that question. So you have a region which has a bunch of patches in it, and there are data, you have some data on which species are present in which patch. And so you can make subsets of patches that have the same total area, but different numbers of patches, and ask, well, how many species are there in the subset? So the 3 patches in the center landscape or sort of pseudo landscape versus the 1 patch on the left, or the however many it is, looks like 10 patches on the right. So this is a gradient going from low to high fragmentation for the same total amount of habitat. Right, so subsets with the same total amount of habitat. And in the terminology that came from Diamond's paper, we use the term SLOS. So that's single large or several small. It's actually we're actually going from single large to sort of few large-ish. We'll call that SL for single large versus several small SS. So almost immediately, people started doing this type of test. And even by 1982, there were enough that Simberloff and Abeel did a review of them and found, quoting their paper, not a single case where one large site unequivocally excelled several small ones in terms of the number of species present, and many more cases where several small sites clearly contained more species than the one large one. And then a few years later, Quinn and Harrison did another review and found that in all cases where a consistent effect of subdivision, so that's what I'm calling fragmentation, subdivision is observed, the more subdivided collection of islands or isolates, which means patches, contain more species. Okay, so this is the opposite of Diamond's principle. And then just last year, I guess I published an updated review of all the papers that have been done that I could find since then. And in fact, found again that there were many more. I did find a few cases, 8, a few cases where there were more species in a few large patches, but there were 5 times as many cases where there are more species in several small than few large patches. So generally there's either no difference or there's more species in many small patches than in a small number of large patches. And you're probably wondering about, are the species in the small patches all of the sort of generalist species? And that does not appear to be true. So some of the authors in this review that I did had split out the specialist and threatened groups of species. And again, the vast majority of those found either no difference between single large and several small, or in fact, the majority found more species in several small patches than in a few large patches. And so just moving back to wetlands again, among the 58 studies that I found, there were, I think, 9 where people looked at some sort of wetland or pond or comparison. And again, comparing the total number of species in a few large ponds versus the number in several small ponds with the same total area. So it's a per area comparison. And there were no cases where there were more species in the few large ponds than the several small. And there were the majority of cases, so I've coded that in purple here. I guess I should have mentioned that in the previous slides, but the majority of cases, again, found more species in several small ponds than in few large ponds. And as I think Thomas said, those ponds the small ponds often have rare species that don't occur elsewhere in the system. So there's they contain species kind of different from each other, which is what adds up to the high diversity across a set of small ponds. Okay, so moving to the third part of my talk, I'm probably going through this pretty quickly, so hopefully there'll be some time for questions, but I tend to talk fast. All right, so the third part is, why is it hard to change the patch or pond size paradigm? So this is the paradigm that says you get higher biodiversity in large patches or ponds than in small ones, even if you have a set of them that add up to the same area as the large ones. And yet all the data that we have seem to suggest the opposite is true. So why is it hard to change this, given that we started with Diamond back in the 1970s? We had these reviews in the 1980s showing the opposite, and yet here we are in 2021, and we still have this idea that size itself is somehow adds value to an area of habitat, as different from the total area, let's say, in comparison to small patches of habitat. So these are largely my just ideas about why it's been hard to change this. And I think the first one is intuition. So I have been working on this issue of habitat fragmentation for a few decades now. And so when people ask me what I work on, people that aren't biologists or ecologists ask me what I work on, I explain this comparison to them. And without telling them, I don't use the word fragmentation. I just talk about large and small and the total being the same and all that. And then I ask them what they think. And often they will say, probably most often they will say what they think that a big one would be better than many small ones. So there is something kind of intuitive about this, just generally intuitive about this. And I don't think researchers are any less subject to intuition than other people in my neighborhood. And so one of the books that I've read in the last couple of years that I found very interesting on this topic is this one called Thinking Fast and Slow, which actually talks about how our intuition, it often leads us to incorrect conclusions. And so anyway, I recommend this book if you haven't read this, but it really, relying on our intuition is really not a good idea, even though it's very hard to stop ourselves from doing that. Another thing that we do as researchers often, I think, is value ideas over data. And this is all related to the intuition thing, because our ideas are often kind of come out of our intuition. And so then when we have data that go against them, we're either surprised or we ignore it, which I'll show you later. But this is just a quote from a discussion section of one of these SLOS, single large or several small papers that I reviewed in the 2020 paper. And so this study found more species in several small than few large, but was surprised. So this is in the discussion, the surprising observation that patchy habitat supported more butterfly species than did the same area composed of one or two fragments, even when only endangered species were considered. So why is that surprising? It's not surprising based on the data. All the data that were available up to the point that this study was done suggested that this should be what we expect. But it was surprising because of the ideas that we have written about in the literature. We have models and theory and other just statements, ideas that suggest the opposite, and somehow we've valued those over the data that were there. So those are ideas for why we ignore this the data, I guess, based on our expectations. Then I think there are some issues to do with presentation. So one thing is that there's a tendency, and I think it's growing, toward sort of hyperbole in the literature. So here's the title of a high impact paper, Habitat Fragmentation and Its Lasting Impact on Earth's Ecosystems. So that is a pretty strong title, I think. And if you're a busy person, maybe not a researcher, but working for, let's say, a conservation group, you're not going to read the paper, but when you read that title, you're going to know what it says, and you're just going to, it's going to influence what you think. And you can see that type of influence by this type of statement from a conservation group's website. Habitat fragmentation is a major problem across the earth. So as researchers, I think we should maybe be thinking about this type of hyperbole and the effect that it can have. There's also, and related to this, there are sort of inappropriate citations within papers. So here are two opening statements. So often we're making these statements at the beginning of papers, either with no citation because we think it's self-evident, or with a citation that doesn't actually demonstrate what we're saying. So habitat fragmentation is a major driver of biodiversity loss. People might cite Diamond for that, for example, or the theory of island biogeography, MacArthur and Wilson, things like that, which don't actually demonstrate this point. So that's also a big problem. And then there's also reporting biases in our presentation. And I'm going to give an example of this from the stuff that I've done. So this is from a review, not the SLOS review, but a review in 2017 that included some SLOS papers, but other papers as well, looking at the effects of habitat fragmentation independent of habitat loss. And then after doing that paper, I did an analysis to see how people represent their results. So these are papers that did control for habitat amount in estimating the effects of habitat fragmentation. There were I think there were 118 studies. A few of them found only negative fragmentation effects. A few of them found only positive fragmentation effects. And actually, most of them found only positive fragmentation effects. And then a lot of them found also effects in both directions. So the question was, how do they represent these results in the abstracts of the papers? So did they represent the effects of fragmentation as negative or as positive or as neutral, sort of mixed effects, or did they ignore the fragmentation results altogether? So if you look at the small number of studies that found only negative fragmentation effects, the majority of the abstracts reported those as negative fragmentation effects. If you look at the studies that found both directions, so some, maybe they studied one species, species A, and it showed a positive fragmentation effect, and species B showed a negative fragmentation effect, then they generally reported those as sort of neutral or mixed fragmentation effects in the abstracts. But if you look at the studies that found only positive effects of habitat fragmentation, only 40% of those actually said that in the abstract. Most of them, the rest of them, the 60 or so % of them, described those, their fragmentation effects as neutral or mixed in the abstract, or they ignored the fragmentation effect altogether in the abstract. So there's a bias that goes into how we present our results based on our expectations. So the third reason why I think this paradigm has been hard to kind of dislodge is kind of emotional. It's a projection of our values is one of those. And here I'm thinking about our value system says that, especially as ecologists, says that large natural areas are important. And, you know, those of us that like to go on a canoe trip, you really can't go on a canoe trip unless you are in a large natural area, you know, a multi-day canoe trip. So, so we tend to, I think, maybe extrapolate from our, you know, what we think is valuable to a statement of value for nature. Then there's the issue of careers. So because this idea has been going on for so long, since the 1970s, you know, careers have been built on it. And it's interesting. I mean, I find that younger researchers are much more willing to question whether this is true than older researchers. This is just anecdotal, but this is in interacting with people, this is what I find. And I think it's because it's really hard after you've been working on something and especially once you've been saying something for 30 years to then say, well, maybe, you know, maybe that isn't exactly quite right. You know, maybe that inference cannot be made from these data. And then there's also this issue that we might be afraid of misinterpretation. And I've had this with reviews, for example, where a reviewer will say, okay, well, your data or your review suggests that, you know, a set of small patches is as valuable to biodiversity as a small set of large patches. But if you say that fragmentation has no effect, or when it does have an effect, it's more likely to be positive than negative, people are going to start chopping up habitat. They're going to start removing habitat to fragment it. But the problem with that is, of course, then they're removing habitat. So you don't have the same amount of habitat remaining. So we have to be very careful about how we describe the results, but we shouldn't misrepresent the results for fear of that they will be misinterpreted for some negative conservation end. So I'm just going to end this part of the talk. So this is the third section with this. This is a recent paper that has just come out talking about evidence bridges, and I think it's maybe relevant here with Ponderful. So the idea here is that we have researchers on one side, and from everything I heard this morning, I think Ponderful is in the category of research. And then we have practice on the right side. So that would include even high-level policy, let's say Ramsar type policy, all the way down to individual wetlands and decisions that maybe a municipality are making about individual wetlands. And I think if we had a set of organizations in the middle that were not research focused and we're not practice focused, but we're focused on the connection between the two, then we might get a little bit more sort of evidence-based practice, evidence-based decision-making in conservation. So these would be organizations that synthesize and communicate evidence. They don't rely on opinion. So it's it would explicitly be about not asking experts for their opinion, but synthesizing evidence that's available, actual evidence, and then communicating in both directions. So what evidence do we have? Communicating that to practitioners, and what needs do we have, and possibly evidence as well from practitioners, and communicating that to researchers. And then the other thing is they should be easy to find, easy to access, and easy to understand, so that this transfer of this communication is effective and actually has an effect. That was redundant. Okay, so the fourth section of this talk is I'm going to come back to Eastern Ontario, where I am, and just share a few of the results about wetland protection that we've had in my lab. So I'm going to start with this. This is a study by Pauline Canal, a former PhD student, who found that ponds surrounded by more other wetlands within 500 to 1500 meters are more likely to contain threatened wetland birds. So the amount of habitat in the form of other wetlands or other ponds surrounding a given pond is important for the biodiversity that's found within that pond. And that's within 500 to 1500 meters. This is Teresa Patnaud, former graduate student, who looked at urban ponds. Actually, she selected the ponds to compare the effect of that surrounding wetland amount with the effect of impervious surface. So urbanization, streets and buildings and basically impervious surface. And she was looking at plant and invertebrate communities in these ponds. And so she selected her wetlands to try to make sure that the amount of ponds surrounding the wetlands and the amount of impervious surface were not too highly correlated. So they're pretty much uncorrelated. And what she found was that the effect of this, the additional wetland in the surrounding landscape was more important to the diversity of plant and invertebrate communities than was the amount of impervious surface. So that's, I think, an interesting result, especially for urban wetlands, where the focus is often on runoff, pollutants running off those impervious surfaces. So this is results from three different people in different studies. So Pauline Canal again, and Alex Kamaris, a former student, and Felix Eigenbrod, who some of you might know. He's now Prof at Southampton. He did his PhD in my lab, and so we have found that ponds surrounded by more forest within 500 to 1,000 meters have higher abundances of several amphibian species and 2 threatened turtle species. And then Felix's study, actually, he did a similar thing to what Teresa did with the impervious surfaces and the wetlands, but he selected his sites to look at the independent effects of forest cover within the surrounding landscapes and road traffic density on amphibians. And he found for some of the species and for species richness, strong effects of traffic density within 500 to 1500 meters. Negative effects on several of the amphibian species. And then I had another, I don't have her picture here, but Lori Carr had looked at this for quite a few years ago now for one species, leopard frogs, and she found the same thing. And in fact, in Felix's case, he had this independent comparison of forest cover and traffic density. And he actually found that if you look at the overall picture, the effects of the two were on a similar scale, so order of magnitude. So the traffic density is really quite important. Sorry. Then I mentioned the ditches at the beginning. So this is results from a study by former student Sarah Collins. So here we're including ditches as ponds. And so Sarah showed that ponds or ditches surrounded by more intensive agriculture and less forest within 1,000 meters have lower water quality in terms of the toxic, agrochemicals present, and they also have it has effects on oxygen content, and also lower benthic invertebrate richness. So benthic invertebrates, that's what I can't remember. I think it might have been Thomas was talking about those invertebrates that are on the bottom of the pond. So they have so surrounded by more intensive agriculture and less forest, lower water quality and lower benthic invertebrate richness. She also looked at the heterogeneity of the farmland within 1,000 meters of these sites. And she was looking at this, in this case, at amphibians. So heterogeneity of the farmland, for this, we have two axes. On one axis, we have the number of crop types. So in this diagram, so this is maybe a 2 kilometer by 2 kilometer landscape, it represents a landscape, each of these squares. And the one on the left has 2 types of crop in it, and the one on the right has 4 types of crop. So, so she looked at the across, I don't remember how many landscapes. She looked at the diversity, this abundance and species richness of amphibians, and found positive effects of crop diversity on both richness and abundance of amphibians. And then the other axis of crop heterogeneity is the sort of complexity of the pattern of the crop fields. So for each of the low crop diversity and high crop diversity, you can have many small patches of crops. So in other words, many small fields or a few large fields. And so this is all about the average, the mean field size. And what she found here was negative effects of increasing mean field size on richness and abundance of amphibians. So, so that's kind of a summary of a bunch of different projects that have been done in my lab looking at the effects of landscape context on various measures in wetlands and ponds and ditches, and finding strong effects in many cases. So, then we asked the question, okay, so we're finding these effects at these large spatial extents, 1 kilometer, 500 meters, 1 kilometer, 1,500 meters. And that is in contrast to the sort of common thing that's done to try to protect wetlands. So obviously we have to protect wetlands from being drained or filled. That's the first step. But then beyond that, how do we protect them in terms of the quality of the wetland? So, so the typical thing is a so-called wetland buffer. Here are 2 different definitions of wetland buffers, but you get the general idea. It's natural vegetation surrounding a wetland to protect it from, in the case of an urban wetland, from nearby development, and in the case of an agricultural wetland, or a pond and a farm pond to protect it from the agricultural activities. So a student, oh no, yes, I didn't mention this. So most of these wetland buffers are on the order of, say, 12 to 20. So well, this is an example for New Hampshire, but these are sort of typical widths of mandated wetland buffers, sort of in the 12 meter to say 30 meter zone is quite typical for mandated wetland buffers. So quite small compared to these landscape scale effects that we've been documenting. So the question is, well, can you get as much benefit from these wetland buffers as from worrying about how to manage the whole landscape, which of course is a lot more complicated. So I had a student, Margaret Salathe, who looked at this question. She first had to contact a bunch of people in policy to find out how wetland buffer compliance is kind of conceived. And there are these different ways of doing that. So one is just to ask out to what distance do you have natural habitat. Another is how much natural habitat do you have within the recommended distance. Another one is how much of the edge of the wetland itself has natural habitat out to the extent of the recommended distance. And then, so she looked at again the water quality in terms of these agrochemicals in ponds across our region, and also she looked at amphibians, and she compared the effects of these wetland buffers to the effects of the landscape composition at multiple spatial extents. And what she found is that really there's very little, if any, effect of buffer compliance. And there are these effects. I mean, she also found the types of effects that we had found in previous studies of the landscape context on these wetland measures. And so not to confuse the word wetland buffer with the word buffer in GIS. So if you're thinking, like buffers, people talk about a buffer just in terms of what's in the landscape, and like out to whatever distance in the sort of GIS world. But if you actually map Eastern Ontario with 1,500 meter buffers around all the remaining wetlands, you would pretty much have to manage, the entire region, which makes sense actually. And in fact, if we had the wetlands that we had, even that we had maybe 100 years ago, the whole thing would be blue. Okay, so in this talk, just to remind you, this is where we've been. The point that small wetlands often have little or no protection. I gave you the example of Eastern Ontario, but you probably have other examples in mind. And that this is in contrast to the results that have shown that on a per area basis, small wetlands, and in fact, small patches of all kinds, contribute as much as or more to biodiversity on a per area basis as large wetlands. So I did some speculating on why it's hard to change this paradigm that small wetlands have relatively little or no protection. So some ideas based on our expectations, how we present work, and just our basic emotions. And then I talked a little bit about evidence bridges and just grasping at what can be done to try to counter this. All of these things that tend to push us in one thinking in one particular way, which appears to be not the direction that the data point in. And then finally, protecting wetlands requires protecting landscapes, not just buffers or wetland buffers. So thank you very much for your attention. And again, thank you for inviting me to this event.
Thank you, Lenore. There would be, as there would have been after all the talks, a great storm of applause now if we all could clap That was fantastic. Thank you very much. It's very interesting to hear that from the European perspective. I'm gonna cheat by being the chair. I want to ask you, first of all, we've got time for a couple of quick questions. Do you ever get at all depressed by the slowness with which evidence is responded to?
No, I don't. I mean, I think I think like most of us, I'll say most of us researchers that are ecologists, which I think is probably the bulk of the people that are listening. The things that depress me more are the things I see happening around me, like the wetlands that are lost, the patches that are lost. I used to walk through, like my walk home from work through campus. Went through a small wetland, and you know, one day it was there and the next day it was gone. And it's just, you know, you just see this happening all the time. Or I'll have a student that, you know, is trying to figure out their site selection, and so they're talking to a previous student who might have a certain site, and it'll turn out, no, that site is gone, so you can't use that one. I think that we're in it for our concern about nature mostly, and so that is the type of thing that I find depressing. You know, it's confusing more than anything, and that's why you know, and all of those reasons that I gave for why we can't change our mind, it's all sort of speculative. I think, you know, I'm sort of learning and trying to figure this part out as I go along, but I don't find that part depressing. That, you know, it's, yeah.
There are lots of questions in the chat, which I promise people we will come back to properly. I'm just going to pick one area that does sometimes puzzle people a bit, I guess, about the small and large thing. What do you find it as well applying to big creatures? And you probably actually have some big creatures over there. Does it apply to great big things as much as to little things? And at the other extreme, do you think it applies as well to say diatoms and phytoplankton?
So, so in my review, one of the things that I did was for each study, I looked at the size of the sort of replicate landscapes that the author had used as an indicator of something to do with the scale. Like what people are really thinking about is the scale over which the organism uses the environment. And so the idea that that the size of the landscape is some reflection of the author's impression, at least, of how large an area you need to quantify, you know, a population or of whatever this species is. And so the idea there would be that if large organisms with large ranges are more affected by more negatively affected by fragmentation, then you would find that you'd find those effects where the landscapes that are used by the authors are large. And that didn't turn out to be true. So there was really no, across the gradient, and it was 4 or 5 orders of magnitude. So it did have microorganisms, and it did have, it didn't have, you know, polar bears, but it did have some, you know, larger mammals and so on. And yeah, you don't seem to find that. And also, if you just look at the taxa, there wasn't really an effect of taxa on the result as well. So it doesn't seem, and I think the reason, though, it's intuitive, the reason that we're thinking that it might apply more, that negative fragmentation effects might apply more to large species, but I think that's because we know that they require a lot of habitat. So it comes down again to this confounding of the amount of habitat and the number of pieces it's contained in. And so, you know, yeah, you might need, you know, a huge amount of habitat to have, you know, wolves or something, but does it actually need to be one contiguous piece, or can it be multiple disconnected pieces?
Thank you. That's a really good to get that clear, I think. I am going to bring us to a close now. Thank you very much, Lenore, for that. I hope we can stay in touch over the course of the project. We think your work is fantastic, as you probably gathered from us, I hope. So we look forward to being in contact with you over the next few years and sharing our ideas as much as we can. I'm going to share the screen now formally just to close the meeting. I have literally 2 or 3 slides. Let's see if I can bring these up. Here we go. Lovely. So I just want to say thank you to all of my colleagues today for the presentations they've made to introduce Ponderful to you, and I hope you found that interesting and useful. We've been very pleased, of course, to see so many of you attending the meeting today. And as I said earlier on, I hope we can stay in touch with you. Well, I'm sure we will in one way or another be trying to stay in touch with many of you over the course of the next few years. We will be organising further meetings like this. I think we're all learning that being online has some advantages in being able to reach out to lots more people than you might traditionally be able to do, though we will also be having some physical meetings as well, and we'll keep you informed about those as we go along. I'd also add to you that the European Pond Conservation Network, which Ponderful is collaborating very closely with, will shortly be starting a series of either monthly or bi-monthly, I can't remember exactly which it was now, short seminars with individual speakers talking about specific pond-related subjects in more detail. And I hope you might find some of those interesting and a way of keeping in touch with us. And EPCN, and we'll help a bit as well, we'll be sending out some more information about that shortly. You will know as well, of course, that symposium, those of you in Europe, I guess perhaps beyond as well, will know that the Symposium for European Freshwater Sciences are coming up soon, and I just recommend to you the special session on small waters in that, which quite possibly people who are around the table, metaphorically speaking, online today are speaking at, and some of the Ponderful team as well as speaking at. So there'll be another chance for us to meet and hear and talk in a bit more detail than we can in these relatively quick presentations. I think we are at a very interesting time scientifically for freshwater as we begin to discover truly the importance of these marvelous smaller habitats, and part of what's a bit of a reimagining of what freshwater is all about, both running and still. So to me, it feels like a really good time to be doing the sciencey part of Ponderful, and as well a time when the knowledge that we're going to be developing, and I hope developing a bit together, will be critical for the way we protect freshwater biodiversity, because you don't need me to tell you that it's one of the most threatened parts of the natural world. And helping to better understand these habitats and to protect them, to create new ones, to manage existing ones better in the landscapes that we're working in will be vital really for our freshwater biodiversity. So I will just say goodbye to everybody. Thank you very much for your time and your attention today. Thank you again to all the speakers, especially to our special guest speaker and to Ramsar as well. And I hope to see you all again soon. Thank you very much.